processors. So basically, we are not talking about the hardware part of AI, which obviously we've called the computing power. Right. Are you guys able to see my screen? Can you guys see my screen?
Yes, sir, we can.
Okay. So yesterday when we finished, we spoke about how AI processors will be classified into training processors and inference processors. So basically, some of these computing power, some of these processors will be used for training. So when we are training the model, we're going to use these processors such as the Atlas 900 cluster, which is one of the most advanced AI processor. Okay, so we have these processors that are used for model training, and we also have processors that are used in model inference. So among the processors in model inference, we may have examples of CPUs, NPUs, GPUs, and FPGAs. Okay, so these are type of AI processors or AI chips that we actually use in artificial intelligence. Okay, so let me just make sure that I'm recording this. Are you guys able to see my screen?
Yes, sir.
All right. So now, looking at these processors, as we can see, we can have a situation where we need to use the processor on a device. So basically, we've already created our model, and now we've deployed our model on a mobile device as a mobile app. So our device will need to have the correct chip in order for it to be able to use the model as it has to be used, right? So we have processors that will be used on the phone. Remember last time we spoke about NPUs, which are the neural processing unit. So this is an example of a processor being used on device, right? So the features of these processors that are used on end device are usually have a low power consumption, high energy efficiency, inference orientation, low throughput, low latency, and cost sensitivity. So when we look at when we apply it, obviously we apply it on different devices. That means can be on cell phones and all those devices there. So basically, this will help us have maybe applications that can help us with object detections. Just detecting object, detecting the picture, identify what is on the picture. And actually having real-time decision making. Okay, so some of these chips that you can have on on smartphone, so where you can have, when you talk about end devices, it can be a smartphone, it can be a smart speaker, smartwatch, anything that can have an AI. Okay, so that will help you in terms of your voice assistant, facial recognition, predicting the next text or things like that. All right, so basically now you're going to have some chips that already come with the devices. For example, if you're using an iPhone, you have an Apple Neural Engine. If you have a Huawei device, you have the Huawei Ascent Lite. So those are chips that work with that. Okay. So now, in terms of edge computing, so basically, when we want to apply this in cases where we have created smart manufacturing, for example, in a certain industry where AI is busy performing some task, you have it in your smart home. If you have a smart home, you have smart transportation, which involves self-driving cars and all those things. You have in smart finance. So basically, when we talk about, for example, in transportation, so we will use AI to detect different objects and tell the car to stop or to turn, things like that. So basically, we need decision making in real time. So that's why we're going to use this processor, which will help us with inference. Okay, so why do we need to do that? Because if you're dealing, for example, with self-driving cars, the cars have to be fast. The car has to quickly detect different objects and quickly give you a result or something like that, because it's going to be very dangerous if there's any delay on how the data are being transferred, right? So we also have it in smart finance. Okay, so in smart finance, we'll obviously use AI to help us with fraud detections, stock predictions, algorithm trading, so that's how in finance AI can work with all these processes. All right. So, and then we have now, in terms of clouds, we can have a cloud based on training and a cloud based on inference. So basically, the inference is when the model is working on whatever task you created it to work on, but all the information and everything are being done straight from the cloud, not from a local, from a physical location. Okay, so you have processes that will be used for training and processes that will be used for inference. Okay, for training, there's a certain example application. We have a cloud technology. We have can find it in HPC. So what is HPC? HPC just stands for high performance computing. So these are basically those supercomputers that you have. So those high speed computer clusters, those are called HPC, right? So those are high performance computing. Okay, so those computers are used to try and solve all these computational problems, right? Which will require really, really, really massive processing power, memory, and data handling capabilities, right? So to achieve that, we need supercomputers, and these supercomputers are classified as HPC. So when we're dealing with cloud-based training, we will need to use this HPC in order for us to be able to do everything on the cloud. Okay, so when you're using an HPC, so the advantage is that all the tasks will be divided into many processes which are working simultaneously. So you basically have a parallel processing, right? And then you have a high speed, you have a fast communication between nodes. That means when you're training your model, so between nodes, there's a very strong and fast communication. So yeah, so that's the thing. So you can use this cloud-based training processes. Okay. So, and then you have what's next? We have the cloud. In terms of the cloud-based inference, the cloud-based inference, that means that we are already using the model. So we have to now use the model to predict whatever we're trying to predict. So there can be chips that can help you with that. These processors will have a low power consumption and high throughput, high accuracy, distributed deployment. Okay, so this is mostly found in data centers and all those places. Okay. Okay, so in terms of the AI processor development process, we have since the 1994, so we already have a development of different chips. But as time goes, the chips are also really, there's more chips being created, which are used in different type of devices. And this is really helping empower the AI ecosystem. That's why nowadays you can find now AI is really advanced because of the availability of these chips, because of the availability of this computing power, which is really, really helping AI be super accurate. All right. So in terms of technology directions, so we have architectures that are done. We have GPUs, we have FPGAs, we have ASIC, we have brain-inspired processors. And all these processes have their own characteristics, their own advantages and disadvantages, and how you can use them. So depending on your application scenario, you may need to use a GPU or an NPU. Okay, so we have in terms of general computing, the hardcore, the what you call this, the hardware structure that we have. So we have the this general computing will be powered by CPUs. So we have the Kupeng technology, which is something that you're going to learn in terms of hardware, right? So this is mostly used in offices, database, numerical calculations, all that. And then in terms of AI computing powered by GPU, you have companies such as NVIDIA, which create different type of chips, which have a different architecture that will also help train the model. Okay, now to compare CPU to GPU, remember CPU is a central processing unit and GPU is graphical processing unit. And when you think about it, like CPU is mostly doing all the simple operation that software do, like opening a software, saving, and all those things. But the GPU will actually focus more on difficult calculation. The GPU will focus more on the graphical processing unit, right? So that's the GPU, graphical processing unit. So that means the GPU will look at everything that has to do with graphics. You know, you have images, you have videos, you have all those things. So that will be controlled by the GPU, right? So when you look at the CPU, in terms of the design purpose or the way it's the computing is happening, so it's the CPU will basically be used for general purpose computing, but the GPU will be used for parallel data processing. That means you are doing many operations at the same time. So all these computation happening for AI, like you have matrix calculation and all those things are performed by the GPU, right? So that is the advantage of the GPU. Okay, so just to kind of summarize on the main difference between how the CPU operates to how the GPU operates. So when you think about the CPU is like, what can I say? The CPU will be like a smart manager who can really handle a large amount of tasks, right? And it can manage the task one at a time, but it can do it well. But the GPU is like a huge team of workers that is doing the same task, but they have different pieces of data. They're doing it at once, right? So that's the difference. So basically, a GPU will have parallel operation happening at the same time, but the CPU will go one at a time. This is the reason why if you click on many softwares on your computer to open them, they will open one by one. The first one must open, then the second one, then the third one, because that's how the CPU works. It cannot do parallel tasks. Okay, so we have the GPU that's mainly used for pure computing environment, where we're dealing with large-scale independent data. Okay. And then you have the CPU, which is used to process different data type in a highly universal manner. Okay, so basically we have all the arithmetic calculations, symbol calculations that are performed by the CPU. Okay, so in terms of evolution of CPU, the CPU has really changed with time. So we have different capacity. Even when we spoke, I think yesterday, when we spoke about all those core i3, i5, i7, as time is going, those technologies are also growing, which give us access to more applications. Okay, so this is the architecture that this GPU and these processors are following is called the Da Vinci architecture. So next week we're gonna go into details. What is the Da Vinci architecture? How the Da Vinci architecture work? So you understand what is behind those chips, what makes those chips powerful. All right. So that can be, for example, you have the Ascend NPUs, which is designed for AI computing with a high proportion of cube units. We're going to learn about different units that comes when you are creating the when a processor has been created in the architecture of the processor. There's different units that are using different tasks, that are running different tasks. Okay, so so this is the architecture of the Essence AI processor. So we're gonna have a processor system control, right? Which is basically a control CPU. And then we're going to have an AI computing engine, which is considered to be the AI core and AI CPU. This is specifically for AI. And then we have a multi-layer system on chip, is for the cache and the buffers. And then you have the digital vision preprocessing module, DVPP, right? So this will be the architecture of this will be the Da Vinci architecture of these Ascend AI processes. Yeah. Okay, so in the Da Vinci architecture, we're going to have the computing engine first. So we're going to have the computing engine, which is the first of the architecture that we have. Where is it? Okay, so one of the four major structure of the ASIN processor is the AI computing engine, right? So basically, the AI computing engine will have the AI core itself, which is the Da Vinci architecture, and all the small AI CPUs, right? So the Da Vinci was just created to improve AI computation power. So this will help us really create powerful AIs, because now with these AI chips we can perform so many activities in a short time. We can perform many tasks at the same time. So the computer has become more powerful with this, right? So we have the component of the Da Vinci. We have the compute unit, right? We have the storage system and the control unit. And as part of the computer unit, we're going to have a cube unit, a vector unit, and a scalar unit. All right. So, and then we're going to have the storage system, which will have all the storage units of the AI core. And then we have the control unit, which is basically representing the brain of the AI core, right? So have the cube unit, which is part of the compute unit. Okay. Okay, so and then we have the computing unit. Remember, the compute unit will have a cube unit, a vector unit, and a scalar unit. Now that will depend on what type of operation the machine is doing. Then it's going to decide which unit is being used. Okay. So when you look at this, for example, the cube unit will work with the accumulator to perform matrix-related operations. So this is the type of operation that will happen behind in terms of training your model and neural network. So all those calculations, remember, they have to be done using an hardware, and this is how the architecture of it is. Okay. All right, guys. I think next week we're gonna go more into details about how the cube unit will work, how the vector unit will work, and how the scalar unit will work. I think for today, for this week, we can stop here. Is there any question? Okay, guys, I'm just gonna make sure tonight I'm gonna upload every other video that hasn't been uploaded yet for AI. Please make sure you've gone through all the videos, especially if you've missed the class. Make sure you are on the right page. Make sure we are on the same page, so that for your AI exam, everything is going to be easy. All right, guys.